Hello guys, welcome to the channel. So we are here with another interesting problem, which is implement two stacks in an array. The problem is asked by companies like Microsoft, Samsung and Snapdeal. So without any further delay, let me start with the problem statement. It says that your task is to implement two stacks in one array efficiently. Now you need to implement four methods. The first method is about how we push the element into the first stack. After this, we have got a similar method for the second stack as well, right? Then we have a method which is pop1, which is going to pop the element from the first stack, and then it has to return the popped element. If the stack is empty, then it should return -1. And we have got a similar method for the second stack as well. Now these are the four methods that we have to implement. Now one example is given here. So in the example, we are provided a bunch of operations. Let's try to perform each of them. The first operation is we have to push the element 2 into the stack 1. So let's say this is stack 1, we have to push the element 2, right? And this is the top element here. After this, we have to push the element 3 into the same stack. So when we push the element 3, then top pointer is going to point to this particular element, right? After this, we have to push the element 4 into the second stack. So let's say this is the second stack, we have to push the element 4. So let's do it. After this, we have to pop the element from the stack 1, right, which is the current element, which is 3. So we have to return the pop element. 3 will be printed here, and then 3 will be popped out of stack. After this, we have to pop the element from the second stack as well. So once we pop this element, then we will have the output as the current element, and now the top is going to point to this empty space, right? And similarly, this top is now pointing to 2 here. Okay, now we have to perform the pop operation again for the second stack, but second stack is empty here. So if the stack is empty, then return -1. So I'll print -1 here, right? And now I have performed all the operations, so I have got the output as 3 4 -1. So you can see the output here as well. Now one thing that I want you to notice here is I have used two stack here, right? According to the problem, we have to implement these two stacks using a single array. So this is what the problem asks us to do. Now I hope you have understood the problem statement. So let's see how we can solve the problem. Okay, so I have written the same example as given in the problem statement, and the first approach that comes to my mind is let's say this is the array. This is the array of size 6, 1 2 3 4 5. So this is the array. The first approach that I have is I can divide the array into two parts, right? So let's do it. I'm going to divide the array into two equal parts, right? And my top is going to start from this position, and top 2, this is, let's say this is top 1, and this is top 2. So top 2 is going to start from this position, right? And now let me point the stack as well. So this is going to act as the first stack, and this is going to act as the second stack. Whenever we push an element, then the top will point to that current element, right? So let's say I have to push the element 2. So what I'll do is I'll increase the top by one value, then I'll push 2 here, right? So this way the top is now pointing to this element. Similarly, I have to push again one element into the stack 1, right? So this is element 3. So now top is going to increase, and then top will point to this value, and then I will have 3 here, right? Let's do it with stack 2 as well. So in stack 2, I have to push the element 4. So increase the top 2 first, then write the value 4 here, right? After this, I have to pop the element. So pop the element from stack 1. This is the current top element, so I'll return this element, but before that I'll decrease the value of top, right? Now you will say that, hey, the value is not deleted yet, right? But this value now is going to act as a garbage value. This is really interesting. This is going to act as a garbage value. I don't have to delete it explicitly, and when I will come here again in order to push the value, then this value will be overridden, right? I hope you understand this particular thing. So now I have 3 in my output. So I have to perform the same operation again for stack 2, right? So for stack 2, I'll simply pop the element. It's not actually like removing the element, it's just decreasing the pointer top 2, right? And I'll get 4 here. After this, I have to again pop the element. So you can see that now my top 2 is pointing to the starting of stack 2 -1, right? So this is nothing but if this is size by 2, then it's actually pointing to size by 2 -1, right? So in this case I have to return -1. So this is how I can like implement two stacks using one array. So this is the first approach that we have, but there is problem with this approach. First of all, let me show you the code. This is the code, and now I will discuss the problem as well, right? So now let's discuss the problem that we have. The problem is, let's say I keep pushing the element into the stack 1. So let's say first I push the element like 2, then I push 3, then I push 4, right? And then I have to push 5. But you can see here that there is a limitation in the size of stack 1. So now I will not be able to push the element 5, though there is a space in the array, right? You can see that there are 3 empty spaces in the array 1, in this particular array, right? But still I'm not able to like push the element 5 because this particular space is reserved for this stack 2. So this is the problem that we face when we have a kind of fixed memory allocation. So you can say that this is fixed memory allocation, right? So you can see that I have allocated a fixed memory for stack 1 and stack 2, and this is going to give us the problem. Even you can see that how we check the stack is full. If we keep pushing the element, then we check if top 2 is greater than okay, if top 1 is greater than equal to size by 2 minus 1. Size by 2 minus 1 is this one, right? So I can't push any element with the index greater than this particular index. I hope you understand this, right? So this is the problem. Now let's see how we can implement the two stacks using one array efficiently. So now I have the approach 2, right? So I have the top pointer here which is pointing to -1 initially. I have the top 2 pointer which is pointing to size, right? Size, or I will say n. Okay, now how we push element. So let's say I have to push the element 2 into the first stack. So similar approach, I have to first increment the top pointer, then I'll simply push the element 2 here, right? Similarly, again push the element 3, so I'll again increment the pointer, I'll write 3 here. This is how I am going to push. What about top 2? For top 2, whenever I push the element, so I have to decrease the pointer. Let's say I have to push 2, so first I will decrease the pointer, right? Because I am moving the left direction. So after this I'll write the element. Similarly, I'll keep decreasing whenever I have a push operation for stack 2. Now you can see that there is no any limitation on the size of stack 1 and stack 2. But question is, in which condition I'll say that the array is full, right? So this top 1 pointer will keep increasing and this top 2 pointer will keep increasing. Once they have reached a single point, then we can push a single element. After this, top 1 will become greater than top 2, right? So this is the overflow condition. Even if we have like top 1 equal to top 2, so this is again a condition for stack overflow. Why? Because first we are increasing the pointer. So let's say top 1 and top 2 both are pointing to this particular index, and I have to push any element in the stack 1, right? So first I will increase the element. I hope you understand this. First I will increase this top 1, then I'll push the element. So when the moment I increase this top 1, then top 1 becomes greater than top 2, right? So this is the condition that I have to check for overflow. What about underflow? So for underflow, both stack are going to have a different condition. For this, if my top 1 is equal to -1, this is for the first stack, right? And for the second stack, okay, for the second stack, let me draw a separator here. For second stack, I'll write top 2 equals to size, right? This is how I'm going to check the underflow condition. So this is about the implementation of stack 2. We don't have any limitation here. I'll only exit, or I'll only not be able to push the element when the full array becomes like occupied, right? But the problem here was, even if the array is empty, I'm not able to push the element, right? So this is the this is how we can overcome the problem that we have in the approach 1, right? Now what about the implementation? So this is the code that we have, and this is the code. You can see that for pushing element, I am first checking the overflow condition, right? Only after that I'm pushing the like value. This is how I'm pushing the value. What about popping the value? So this is how I'm performing the pop operation for both of these tags, right? So now I hope you have understood the like solution and both the approaches. So now talking about the time complexity. So for this approach, O of 1 for time complexity and O of 1 is the space complexity, right? Okay, space complexity is not O of n, it's actually size, right? So for this particular solution we are using the size as 100, so we can say yes, the complexity is O of 1 here, right? we have the constant size. So this is how we can solve the problem. I hope you guys will like the explanation. Thank you.